Yeah, so thank you very much, Paulo. Yeah, it's really a pleasure to be virtually in Brazil. And just to give you an idea, so this is sort of where I am. I'm like in the Koblenz Bonn area in Rhineland-Palatinate. And this is close to Rhine River and Moser River, so it's also nice here. But anyway, yeah, so I have this somewhat, catchy title. So it's about software engineer career planning in the age of AGI, plus minus. With this, I mean, maybe we are obviously not yet there. We don't yet have artificial general intelligence, so we are also interested in things below that threshold, right? Something like LLM, I mean, large language models. And obviously, I know everything about it. Well, no, not at all, right? So this is totally discussion oriented. And so I very much welcome interruptions, or if you want to wait until the end, it's also fine. I'm totally flexible. So I don't really think of myself as Chuck Norris here, but I like the idea of being somewhat of a research community psychiatrist, because I mean, as Paulo just pointed out, I mean, this is a topic everyone is interested in. This is a topic like, AI, this new challenges around AI. This is a topic every research community has to deal with, and also with regard to education. So, and I've been attending different meetings in different sub-communities around my interest areas, and there's always kind of nuanced discussions. So here I try to have a broader view on software engineering, obviously. And so one of the questions is, of course, if we talk about career planning, so whose careers are we talking about, right? So is this about our bachelor, master, maybe PhD graduates? Do we want to help them to plan their career? Or do we also want to be relevant for deployed software engineers, already working there? Do we want to also say something about the career of junior software engineering researchers before they are tenure track, right? And then maybe also people like me. I mean, I'm not yet retiring. I'm not yet exactly junior, or Paolo, same situation. Well, I mean, obviously we don't need to talk about career planning for retiring people, right? So that's obvious. But no, I think in this talk I kind of focus on those more junior scenarios, right? And also, I mean, these two things that I highlighted are sort of interconnected, obviously, right? I mean, when you think about career planning for your students, you obviously think about, how their skills are relevant once they hit the software engineering in the wild, right? So this is sort of necessarily related. And let me see whether I can move this around a little bit. Yeah, maybe like this. I don't know. So I think there are these elephants in the room. I mean, these are the topics we should talk about when we want to discuss career planning in software engineering, right? So first question, basically, does a modern software engineer, or does the software engineer of the next year or next 5 years, does it weather GPT-4 plus, right? I mean, 4 plus, there will be new versions, obviously. They will get slightly better. I'm not even yet talking about artificial general intelligence, but just, incrementally better large language models, right? Will the software engineer, that we educate, that we see graduating, will this software engineer, will she be relevant, right? And so obviously we should try to have graduates with good skills and competencies. So what are those, right? How do we need to adjust? How does education, methodologically or otherwise, need to be adapted? And also related to research, right? I mean, how does software engineering research need to adapt? And then, we can also ask ourselves, okay, maybe it doesn't look as good for software engineers as it used to be. Maybe we should think about career change. And if so, practically speaking, what should we change to, right? I mean, I don't know, what should we do, right? All right. And so I had this artificial generalized intelligence in the title. To be honest, I'm not going to talk much about AGI. because it's not there yet, arguably. So it's more, it's more obvious to focus maybe on large language models. And for those who are not completely sure about what AGI means, right? This is like, for example, here this Wikipedia definition is a type of hypothetical intelligent agent. It can learn to accomplish any intellectual task that human beings can perform, or maybe more strongly, it surpasses human capabilities in the majority of economically valuable tasks. And I mean, an economically valuable task would also be, software engineer in certain contexts, right? It's not just about being able to generate code. I mean, an AGI would be able to, replace a software engineer more or less entirely, right? So, and here are just some standard characteristics of artificial general intelligence. But as I said, I will not be as advanced that I envision the world at the point we have, proper AGI. And why is that? Well, there's different kinds of estimations when AGI will happen. I mean, some of you might have seen this chart here where they asked lots of experts, when AGI will happen. And as you see, there's enough experts who say it can happen pretty soonish. And, obviously most of them think it happens in the next 100 years. And half of them thinks it's by 61 and so on. And that was actually before ChatGPT came out. So, probably this has shifted a little bit. But anyway, so obviously once we had AGI, then that would just be tremendous, right? And all these domains here would be hugely affected. And maybe even with LLMs, they still are. Well, healthcare, maybe that's not just an issue for generative AI, but, I'm mostly focusing on generative AI here. And so I have lots of references in this talk. So I published the slides. I have an updated slide deck on this talk. And I will not go into much detail on each and every reference, but, there's some cool references here. Also asking about, what can we do about, let's say, generally AGI, right? So, and what I also find interesting is, think a little bit about the broader sociological, perspective here. So will we see, another type of swing riots? Will we see that by software engineers or, by the general public? That's an interesting question, right? But anyway, I just, for the purpose of this talk, assume that AGI will need a bit more time. And also, even if it, gradually comes upon us, we could assume, just for the sake of the argument, that AGI would be highly controlled. It better be, right? I mean, especially when it comes, goes into the direction of singularity, when things would get out of hand. We better assume is, a future in which things are highly controlled. And so for the rest of the talk, I largely focus on large language models, such as GPT. Okay. So is this the time for career change? And if so, to what, right? And I just have a, fun illustration here. I have one instance of software engineer changing his career. This is, I don't know whether anyone knows him. I'm an old person, sort of. So this is Andrea Blakely. He's from Poland. And as you see, like in the 90s and also later, he was very active in denotational semantics and formal methods. But he was an engineer. He was actually a denotational engineer, if you like. So he had a very engineering-like attitude on formal semantics. And then at some point, actually, after, the Poland basically came out of the grab of Soviet Union, he returned to his very old family business of pastry engineering. So he changed his job. He stopped doing denotation semantics, formal methods, and he just went on doing top quality pastry bakery stuff. And he has a very expensive shop in the center of Warsaw. what I'm implying with this is, we can all maybe still change and do something completely different and still have a good time. But of course, we also like our job, and maybe we would like to see whether we can continue being software engineers. So this is sort of the question here. And I mean, if we wanted to do a career change, what would be kind of obvious options here? Should we, move from a software engineer to an ML engineer, or to an ML ops engineer, or to what I would call an ML plumber, just keeping, workflows, ML workflows going, and doing some minor feature engineering, stuff like that? Or should we just get full-blown AI experts? I mean, none of these transitions would be very straightforward, right? Because, just because it's called ML engineer, it's not completely like just a refinement or, derivation from standard software engineering. So I guess it's obvious that none of these transitions would be very easy, right? So anyways, I found a nice article here which kind of tried to use some relatively objective arguments in order to assess the safety of jobs. And I'm not going into the methodology that they use, but of course you can go and read about it. But here's a list of jobs that they say that are safe from artificial intelligence for the next 10, 15, maybe 20 years. And if you look closer, these are all jobs that seem to involve some doing, some, dealing with real stuff. In the real world, in the wild, right? And so that's interesting. So these jobs, they were sort of not very, how should I say, maybe well regarded in many cases, but there's a large potential now again for these jobs. And there is also a list of jobs that are at risk according to this methodology. And luckily for us software engineers, we are not in that list, so that's good news, right? But for example, as you see, mathematicians are right at the top. And I think what they mean here is they mean mathematicians like in an insurance or banking context doing relatively standardized, non-trivial math, which, however, obviously can be automated easily. And so you see many obvious things here, like accountants, right? Accounting is really on the way of being so much standardized that it's not a surprise. And again, software engineering is not on this list, or software developer or anything like that. So that's maybe good news here. And actually, just for fun, I went on the webpage of OpenAI just to see what sort of jobs they are advertising, right? So, and that gives me some hope, because as you see, they are looking for software engineer. So this is the list, how it's just without any tweaking comes up on OpenAI website. So that's good news. So there's at least in the AI context, they at least still need some software engineers. So good news. So just also some more random thoughts here. Obviously, if you look at big tech, for example, I used to work for Microsoft and for Facebook, very well paying organizations, right? So maybe this time is sort of over. Or if you think of a country like India with millions of coders, there might be some very strong impact on the economy, on the whole labor market there. Or if you want to listen to the Google CEO, obviously he's also asked this question 100 times, like how will software development change? Will software engineers at Google or otherwise lose their jobs? And he generalizes quite a bit, and he says, this is a bigger problem, obviously, right? This is a problem of broader societal adaptation, and so pretty much all of us in qualified jobs may need to alter our paths, more or less, right? Yeah, and maybe one slightly more positive remark here. So if you assume that, things like ChatGPT can replace software engineers, you obviously also need to assume that we always have very good requirements on the table, and we can just feed these requirements just into the system, and then we get just perfect code that integrates with everything that's there. So that's obviously luckily naive, right? And then also all these predictions about, what will happen in 5 or 10 years, we don't know, right? I mean, here are just some standard examples about predictions that just went terribly wrong. And I mean, at that time, probably many people believed in it. So I don't know when we are going to change our career. So let me talk a little bit about the impact of LLMs on software engineering and also the limits of LLMs. And I, again, just leverage some sources here that I just quickly point out. I mean, the big change here is basically, and you see this with things like integration also into IDEs, that you can just fire up a simple query and you get a good initial solution, right? So this is already, I don't know how many of you are, also developing stuff, but this is in many places, many developers are already using those tools, right? Actually, you can even ask, as usual, you can make ChatGPT reflect about certain problems. I mean, you can even ask it, how can you help in software engineering, right? And then it just gives you those items here, and I guess you have seen all examples of code generation, right? Or technical information, debugging issues, and so on. I mean, if you have time, I could also talk about some problems that I figured out where, the current generation of tools is not very good at, but certainly it's already a big tool. Yeah, so, and I mean, obviously we are supposed to welcome, and I do welcome, the use of AI tools in the context of development and broader software engineering. And the idea is that we, consider ourselves being one side of the partnership. And so things like GitHub Copilot, it's just your coding companion who helps you to become a better engineer, better coder. And that's of course nice. I mean, and it's also, I think it's also obvious that this kind of very let's say, nerdy developer, being good at somewhat tricky, special problems, I mean, certain subtypes thereof are probably no longer needed, right? Because if this solution space, is well surfaced in the training data, then, ChatGPT will be just as good as any nerd that has this knowledge also acquired by, some corpus. So, yeah, or here's another source that also tries to come up with reasons why AI will replace software developers or not. I mean, this is the first item is like what I said already, right? Someone has to tell the machines what to do. And then the other thing is, and I will give you more examples of this, also based on sources, ChatGPT isn't always right. And the problem is, as you know, ChatGPT doesn't know when it's not right. So someone else has to figure out whether ChatGPT is right, because it can be very costly if you can't assess it and ChatGPT or this sort of AI is not right. Well, I'm not so sure about this creativity thing. This might be relevant in certain contexts. But I think this is to some extent wishful thinking, that every software developer has to be very, very creative. I think it's more important to point out that software engineers have to be somewhat integrated into a bigger team, and but that's sort of taken care of maybe by the first item. And well, also this item here with the who would fix it. I mean, this is I think also wishful thinking, right? I mean, we already know that these large language models can fix code. It's largely a problem at this point of scalability, right? I mean, you cannot just throw a a bad system of some, a million lines of code at a large language model and then make it figure out some complicated bug. I mean, that's the problem of scalability, but the large language model might be able to help you in, narrowing down the search space and then eventually solve the problem in the right scope. Critical thinking, I don't know whether all software engineers are always so critical thinkers. I would like to point out responsibility in this context, right? Because, we as humans are used to the fact that we take responsibility for what we are doing, and this is the social contract in many professions in engineering. And we have to see whether we're willing to, really pass on responsibility to the machines, or whether we actually enjoy the idea as humans to keep the responsibility. But of course, you need to be able to, make responsible decisions. So this is sort of my favorite that we as software engineers should remain in charge, and we should be good enough to assess everything we are doing or what we asked the AI to do. Yep. So maybe quick forward. So this is where a recent article. I don't know whether some of you might have seen it. This is from IEEE Spectrum. Critical look at AI generated software. Very nice article. It brings up some nice issues, but this is also really cool. It just shows us how many tools there are already out there, right? I mean, ChatGPT is just one cell in here, or GitHub Copilot is somewhere over here, right? And all these other tools are also out there to help developers one way or another. So this is interesting. And this article also raises a number of questions. Well, the first question we sort of have already addressed, right? Is AI going to replace human programmers? They basically argue not yet, right? And then they ask the obvious question, is AI written or AI assisted code better than code written by developers not using such tools? Well, and then the obvious answer is sometimes it is and sometimes it is not. And they actually refer a very nice research article. It's called Asleep at the Keyboard, Assessing the Security of GitHub Copilot's Code Contributions. And this is an article which sort of takes a systematic approach, an empirical approach in figuring out whether Copilot's code contributions are prone to vulnerabilities that are already listed in certain, that are accepted problems with security and stuff like that. And they figure out that there are actually many violations in the code. In some cases, they show that if you know what you're doing, you can actually push the AI to actually give you more secure code. But, if you don't know, then, you are just lost. And are there any conceptual concerns with AI-written code? That's also a question from this article. So, for example, you could ask, is it fundamentally okay that we use NL-based systems or NL-stylish systems for code, which we essentially do, right? It's not really using symbolic computations. It doesn't really use semantics, primarily represented. It doesn't have formal understanding of transformations, right? Is this appropriate? Well, I guess we just have to, we have to have appropriate benchmarks to figure out. And there are these metaphysical concerns also, which are just interesting from maybe a philosophical point of view. Does the AI understand the code or not? Maybe we don't care. And then there's also one interesting statement somewhere. I think I also hear this a lot in discussions. In any case, these large language models produce code based on what someone has already written. They cannot come up with generally new programming solutions on their own. I don't like this kind of simplistic, claim, which sort of belittles the large language models. Because, first counter question I would ask, are we sure that, every software engineer needs to come up with truly new programming solutions all the time? Or maybe just often enough? Are we sure about this? I'm not so sure about this. And And then how do we think about the compositional and transfer power that, large language models de facto have? I mean, they can really transfer things from one programming language to the other one. They can really combine solutions in ways that I'm pretty sure this code doesn't exist. So to some extent, this is maybe some sort of emergent property. So I think this is pretty strong. And so I don't think we have a really deep understanding of the theoretical limits of LLMs, and also not, in terms of applications. So, and that gets me to this list of software engineering skills. So I don't have the final answer on this. So we could talk about these hard skills and these soft skills, and we could discuss to what extent the hard skills are more or less taken care of, potentially by GPT-4 Plus or similar technology, similar language models, similar AIs. And then we could go through the soft skills and see how important they are and how their efficient or effective execution of those soft skills requires still those hard skills, at the developer's brain, not just, within the AI. I don't have the final answer on this here, but this brings me back to my sort of favorite, what I mentioned earlier, responsibility. So I think with large language models and we can rely on more help for drafting solutions, for improving solutions, for solving problems, and maybe we can spend more time really on the purpose of the software and thinking about the people who are supposed to use the software. And so this is now, I want to come to a short part, and this is basically almost, I think I have, maybe 10 more minutes, maybe. A short part where I want to say a few words about how I think teaching should be adapted. I mean, sort of informed by the previous discussion, right? And then also for research. So let me start here. Interestingly, I found a nice claim from a faculty member from Harvard. So he says, ChatGPT is not going to destroy software, development, engineering, but it will destroy computer science education. And I think this is interesting. And so he's basically talking about cheating. And so he's really afraid of cheating. And I mean, obviously we have to address this, right? I mean, we have to, I think maybe the mistake, and this claim is a little bit older already. I think by now maybe most people have a more nuanced view on this. Maybe it's just the wrong paradigm to think about, more checking. I mean, if you're just thinking about figuring out that someone has cheated, pretty much in a way of plagiarism detection or something like that, maybe this is not the right methodology. Maybe this is not the right paradigm, right? And I will get to this. Maybe we need to do teaching in a much different way. And so here's my list of don'ts in teaching. I mean, obviously, I think, the train has left the terminal. Don't ban the use of AI. I think that's quite agreeable. Well, but honestly, I have talked to some faculties, in Germany and in the Netherlands, and there are people and there are faculty members in some places who actually want to ban it, right? And similarly, I mean, it's not enough to ban it. I mean, you also have to really integrate it. I mean, you shouldn't ignore the new possibilities, right? You should integrate it into teaching. And then the third one is more operational, and that relates to the cheating thing on the previous slide. I don't want to be in a business of grading homework that could be or is likely done by a large language model. I think this is just completely stupid. And I will mention this. I have 2 courses where this would be relevant, and I have changed them right away for the summer semester. so that I'm not, because I mean, this is very demotivating for everyone, right? So, I mean, you are wasting maybe resources then on figuring out that they have used an LLM, and or you give them a good grade because they have used LLM and they're stupid, they cannot do it themselves. So this is I think this is very important. And then don't aim at outsmarting the AI. I mean, outsmarting. Let's merge 4 and 5. Outsmarting and belittling the AI. I have seen this also. Actually quite intelligent researchers. They throw some prompt at ChatGPT, and then they have this haha event. It can't do that. And then I'm just telling them, maybe your prompt was not fair. Maybe if you ask a random software engineer on the street with this little information, and you provide zero context. Maybe this would be exactly the same quality of result that you're getting. And so this is obviously not a good idea. Yes, and don't downplay the problem. I mean, it's a big challenge for society. It's a big challenge for labor market. It's a social problem. So the last one, don't demonize software engineering. By this I mean we are humans. And we should, we should celebrate to be humans. I mean, okay, if you believe in singularity or AGI, there might be smarter entities on this planet at some point soon, maybe. But we are still humans. I mean, we should take care of ourselves, and we should, for as long as we can, we should keep the human element in software engineering. And, we want to keep ourselves busy. So, sort of a pragmatic way to look at it. And here's the other list, what I advise people to do. I mean, it's sort of, the complement to some extent of the previous list. Obviously, you should encourage LLM for productivity. You should always aim at increasingly structured AI use, such as prompt engineering. We need to find a good way of declaring sources when we use AI. That we haven't really figured out completely how to do this. There are many proposals out there, but I mean, it's much more complicated than with author statements or with citation or quotation best practices. And then the fourth one, that's my proposal to deal with this generated homework issue. We have to use human-to-human interaction for validation. So, rather than, trying to have the student generate code and then we use a better machine or the same machine to figure out that the code was generated and, so human-to-human interaction. Keep the machine out of some validation part. And then, which sort of implies that the teaching formats need to be more interactive. I mean, so this is the added value of, having humans in the room. We like to talk to humans. We like to see humans. So make teaching formats more interactive. Of course, in order to become better at AI and also in the software engineering context, we should, of course, revisit our teaching objectives to make some room. But this has happened all the time throughout the history of computer science education. We always shift priorities for the teaching objectives or for the topics also, as we progress. And the seventh one is also very important to me. As a society, we are going to have really huge problems if we just, keep on going with this AI progress in an unchecked manner. And as technical people, as, software engineering folks who are close to the operational part of AI, we need to get very deeply involved in AI ethics and policy, and we also need to tell us our students. Just as an example of structured AI usage, here's some advice on best prompts for software engineers. How should you use ChatGPT in a structured way to solve certain problems? Just flash this. I don't go into detail. And here's one of my courses that I'm doing in this semester. I mean, actually, both programming-oriented courses are done like this. One is Introduction to Functional Programming, and the other one is programming language theory, but however based on interpreters, so it's also programming-oriented. And in these courses, I do no longer expect any assignments where they somehow can qualify for the exam or get some brownie points for the exam or anything like this. No, they have to present their solutions in class. And in order to know whether they really know what they are doing, there's a question and answer format. So, I mean, they might have learned how to explain the stuff. That's clear. But, we will immediately ask them, what if you would do it differently? How would you do it? How would you implement an additional requirements? And the problem is, of course, there's a scalability issue. I mean, where we could previously take in many assignment solutions and partially automatically grade them, right? This doesn't work with presentation-oriented format, but if we simply make it work by lowering the amount of presentations they have to do compared to the submissions they would previously need to submit, I mean, it seems to work. So I get good feedback so far, but both courses are still going on. And then last part, research adaptation, which is sort of related to, software engineering career, software engineering teaching. So this is not an exhaustive list of fields where I think, that might be affected by, increasing AI relevance. So I think empirical research will be less relevant, and by less relevant, I mean that level of empirical research that we have today, that will not be really genuine human research necessarily, because for a large part you can automate it. So of course, I mean, coming up with relevant research questions, and verifying the methodology and everything, and figuring out threads of validity. I mean, for some time this will be still important, but in certain areas, maybe less so in software engineering, I don't know. In certain areas, empirical research will be largely automated, at least at the level we have now. I mean, of course, there's a potential then, that we can do more meta studies or stuff like that. We can go deeper into some areas, right? For software development lifecycle and human-computer interaction, I'm not sure. I don't have a personal opinion. Trustworthiness of systems, including AI policy and ethics. This is going to be a very important problem, right? As we kind of delegate more work to systems, and as we get maybe more generated parts of the systems, trustworthiness is going to be very important. Do we have compliance? Do we have resilience? Do we have explainability? And is everything in also aligned with reasonable AI policy and ethics? This will be more important, and ML engineering, ML ops will naturally go up. Also, interesting kind of side issue is sustainability, right? Everyone is setting up more and more GPUs, but I mean, we are burning a lot of energy like this, right? So this kind of sustainability issue, that's certainly one element of the ML engineering, ML ops part that we need to look into. And then, generally ML as a domain in terms of also, system architectures for AI, that's also going to be more important. And then sort of final slide here. So if you don't look into fields, but more generally how software engineering research might adopt, well, I think we will try to delegate quantitative work. I mean, what I just talked about with empirical research. We are totally fine to get methodological inspiration from the AI. I mean, that's also cool for students, right? I mean, students can, when they work on their thesis, they can actually ask a large language model for, some initial structure, or they can play with it. I mean, it's like a very informed fellow student they can work with. That's great. And doing systematic literature surveys or reviews, that will also eventually be possible. I mean, I have the side note here. Much of this does not work very well with current LLMs, right? As you probably know, for example, GPT is not very good at actually providing sources of what it's doing, right? Where it's getting it from. It actually hallucinates about scientific works and all this. But I mean, obviously this will get better soon. And when you think about certain areas of software engineering, such as automated software engineering or mining software repositories, we can use large language models to actually script certain parts of the work, which is very nice, right? So it will be much easier to execute research. And that's my that's my closing slide. So, my slogan is, we want to keep software engineering sufficiently human, right? And I think the software engineer of the future needs to be even more human than, the current, maybe possibly nerdy software engineer. Software engineers shouldn't try to be a large language model, right? That's now a lost case. And we need to really think about AI ethics and policy. And the discussion topics I want to propose, but I'm completely open to what you have in mind. So your experiences with the use of AI in teaching, I would be really interested, and also your experience with the use of AI in research. And, since we were talking about career planning, have you seen already some impact on software engineering careers you want to share? So, thank you, Paulo. Thank you, everyone. Look forward to some discussion. Thank you.
Thanks a lot, Ralf. The presentation was very nice, and lots of puzzling arguments, and it will be very good to digest these a little bit here with the questions and comments. So people, please raise your hands or write your messages on the chat, questions on the chat. But let me start with a couple of questions, maybe while people take some time to write the questions there. And so Jacques already has one here. So okay, go ahead, Giles.
Okay, can you hear me?
Yes.
Yeah.
Okay. Thank you for the great talk. So I was wondering if you can go back to the slide with the 30 past chat GPT prompts for software engineers. And one of your slides. Yeah, this one. Okay. So coming from the requirement engineering community, I am very pleased to see this. So basically what you are sharing with us is that, okay, we have to be a good requirement engineer in order to be a good user of these large language models. So this is well known, right? Before we already had to do at least these 3 or 4 first topic, right? So if you don't know what you need to be done, okay, and if you cannot express what you need, okay, and you cannot provide the domain assumption, the context, etc., you have no chance to getting it right. So this is basically what we need to get the right. So
Great.
What your views on this? I mean, are we having another goal? It's a prerequisite for doing good AI-based software engineering.
Yeah, very, very good observation. I mean, I'm not formally educated requirement engineer myself. I'm actually a bit more from formal side of things. So I like to, give some formal specification, like, abstract data types or semantics, which obviously doesn't work for all problems, right? But it's interesting that because we are in this natural language context, we might really see a renewed, maybe requirements engineering can really have a broad impact on a broader use of prompt engineering. I mean, so I have also executed this sort of methodology for a bunch of problems, like for example, software reverse engineering, software re-engineering problems, or simple mining software repository problems, and of course, programming exercises. Yeah, I mean, I think, and I think this is just a very general template here. These 1, 2, 4, 3, 5, and I think it could be interesting to get more specific, to have more, more refined patterns of, discussion. Yeah, that's very interesting.
Okay, hi Ralf. So another question was, I thought it was interesting your approach for teaching the students on programming skills, and so it's interesting that you base your approach on those questions and answers. But shouldn't the students also very good at using ChatGPT, and maybe the first kind of task that you had done submitting code assignment could maybe measure how good they are using ChatGPT?
That's a great idea to actually make similar like to other skills, right? Are they good at testing? Are they good at using an IDE? Patterns. Yeah, I mean, that's an interesting idea to explicitly add the large language model usage skill. I haven't done this so far, but I think it's cool. Actually, I mean, I do encourage them to use, but I don't really tell them too much about it. I give them a few examples. Actually, in my lectures, which is also very interactive, so where I basically just develop typically, code. I always sometimes start with a little discussion with ChatGPT to, just ask ChatGPT what I should do, and then I reflect on what sort of advice it gives me, and then I, revise it. But yeah, that's a good point. I think this I will pick up this suggestion. That's a good idea for next year. Yep.
Okay, Rodrigo now has a question. Rodrigo, go now, Rodrigo.
Ah,
Yes.
Rodrigo. Hi, Rodrigo.
Thank you for the really nice talk, Ralf. From our side here in Brasilia, what we have observed so far is that all this new AI stuff have already changed the funding support for research. My question is, have you also observed any for research funding in Germany?
So this is about funding, yeah?
Yes.
Yeah. Well, I actually are part of a project at a university where we take an interdisciplinary approach to integration of AI into the teaching curricula in a responsible manner. So basically, we want to, not just in computer science, everywhere, we want to integrate AI into at different skill levels, and so we do have some funding, but to be honest, I haven't used that funding so far, for example, for any large-scale empirical research with any language model. And in some master theses that are just started, we actually use like not GPT-3 or 4. We use simpler pre-trained models, right, that are sort of open and that are scalable enough. Yeah, I mean, this is definitely a problem, and also the fact that the interfaces change and the licenses change, and that the deployed thing changes, so it's very, very hard to reproduce. Yeah, but I think funding ultimately shouldn't be that much of a problem. I mean, for any sort of AI research already for a long time, you would need some, cloud capacity. So I think it just maybe shifts money from here to there a little bit, but I don't know.
What we have is that most of the calls for funding include something like group learning or learning and
Yeah.
so on. So we have to somehow machine learning.
Yeah.
So it takes off.
Yep, yeah, Rodrigo, thanks. But in Germany, indeed, we have sort of the common scheme that the National Science Foundation or also other funding agencies, you can apply for larger infrastructural projects separately. So, usually when you do a basic research project, you have to prove that you have the infrastructure already ready. But you can usually, when you can have separate applications to build up your infrastructure. Problem is with the large language models being sort of, that's a very unstable thing right now, and it's very difficult at this point to research at the top of the the LLM stuff going on. That's very difficult. Yeah.
There's a question here in the chat, and Rafael Lins, he's asking about the quality of the programs generated by ChatGPT in terms of runtime efficiency, portability, readability, maintainability, and other utilities probably. So do you have an account about that?
Obviously the only serious way to answer this would need to be based on some sort of empirical methodology. And I mentioned this article from the IEEE Spectrum article being referenced from there, which was looking into security vulnerabilities. And that one was taking a systematic approach. It would basically go through a well-known list of all these security issues and then systematically translate this into code generation prompts and do this for different implementation languages, and then they had a very precise understanding what percentage, and it was significant percentage. It was sort of, like almost 50-50, where there were some issues. And for, again, some significant part thereof, they were not able, even with knowledge, to get rid of these issues just by tweaking the prompt. And with regard to any other characteristics or areas, like maintainability, performance, I'm not aware of any very systematic approach. Of course, many of us have anecdotal evidence. I can say that I, for example, took my programming task from my programming class, Introduction Function Programming. I took a few of them and threw them at ChatGPT, the previous version, and the solutions were, I would say, significantly better than the average student. And then, of course, I was challenged. That was like this early attitude, let's challenge the AI, it can't be that smart, right? So I was basically increasing the complexity of the programming task. And, and then I would eventually hit an area where the solutions, where it couldn't really give necessarily very good solutions. But then I was thinking of the poor student. The poor student would not be able to solve those tasks at all. And maybe I wouldn't be able to solve them. I'm just generating my favorite programming tasks. And then, we need more empirical research on this. That's a very interesting thing. I'm actually working a little bit on this in a mining software repository context. We try to get some empirical evidence on the suitability of the tasks that are solved by ChatGPT. But I'm pretty sure that we're going to see lots of papers on this.
Okay, there is another very interesting question here by Van de Berg. Silva dos Santos, he's asking about if AI is going to make life harder for young software developers. This is because, the skills that are harder to replace with AI, they are more prevalent on experienced software developers. So how do you see that?
Yeah, you could ask, is it getting harder for younger software engineers, or maybe it's getting harder for older software engineers? Because obviously we have now quite a transition, right? Or it's actually not a transition. It's like an irregularity. Like it's a non-continuous kind of development. So you could argue all the acquired experiences, especially at the coding level, of more experienced software engineers are slightly, neutralized or put into an equilibrium. And for a young, software engineer who might be very open to these new technologies. So I don't know. I think this it basically in the end boils down to the question how the software industry develops. Whether we see a huge reduction of software developers exactly when, we don't know, right? But yeah, I would think it's not particularly difficult for young software engineers.
Okay, thanks. Now, Augusto Sampaio, Professor Augusto Sampaio.
So, hello, Ralf. Thanks very much for the nice talk. I looked at formal methods and I wanted to have an experience and explored how far are we from getting effective help from this kind of technique to help with formal verification. For example, I keep thinking about even model checking, that we need to do lots of abstractions in the model so that we can actually avoid the state explosion problem, or even if we go to still improving even more elaborate stuff we need to do. So do you think you'll get to the stage where we really have some effective help in this direction?
So this is a really cool question, and I mean I also know that, for example, Paulo is also interested in formal methods, such as proving correctness of refactoring, so stuff like that. This is a very interesting question, and I'm sort of trying to look into this. Well, and I would like to collaborate with you guys if you are interested. So I think the general question I smell here is whether large language models are sort of successfully competing with non-trivial symbolic computations, right? I mean, you mentioned model checking. That's definitely a non-trivial symbolic computation, but you can start before this. You can take something like refactoring in itself, or which is usually also pattern-based and highly semantically constrained translation process, or you can take something like partial evaluation, compiler optimizations, right? All these things are they feel like they are bound to be symbolically executed on on the good old architectures that we have been used to. And then you try a few examples, and then you realize actually the large language model has learned quite some skills here. It's not just that it can add; it actually can do certain kinds of refactorings. And so then the question comes up: is this how well does it scale, right? I mean, obviously we have a huge scalability issue. I mean, you cannot arbitrarily increase the prompt size, right? It's just very expensive. I mean, in terms of energy and everything. And that's an interesting question. I mean, again, in terms of sustainability, how much should we, try to source out to large language models? But then you can also ask, maybe we can integrate model checking and other such symbolic computation things into large language models. And to some extent, I believe, OpenAI has done this without telling us very clearly. So this is very interesting research area, right? And I mean, I'm sort of a language engineer. I'm a grammar nerd, and for me it's interesting to see how precisely large language model has learned grammars without, of course, internally representing them necessarily as context-free grammars or otherwise. But it just works, right? So So this I think this is a very interesting research area to understand how to combine classic methods, model checking, other symbolic computations with large language models, and also look critically in the sustainability issues of overreaching in the use of LLMs for problems that it was not meant for to solve efficiently.
Thanks.
Thanks, Ralf. I was at least maybe a couple of last questions. Let me make one here. It's about the empirical research argument that you made. I'm not sure if I got it completely, Because do you mean that it will be automated in a way that you just give a research question and the AI machine provides an answer to the research question, and I just have to verify how it managed to get that, something like that?
Yeah, that's pretty much what I mean. And that sounds, of course, I mean, I don't think we can do this year or maybe next year. I mean, not reasonably. But it sort of relates to this claim that mathematicians are going to be less relevant. In any sort of domain where we have highly standardized methodologies, in empirical research, we have a body of statistical methods and certain tests. And actually, humans these days are very proud of being able to correctly apply these rather complicated, mathematically intensive methodologies. But, once the LLM has understood them, this is, it's no longer a challenge. It's just, it's pretty similar to, being extremely good at writing force code or doing, tricky optimizations in C. I mean, it's a skill that can be learned from a corpus. And of course, it's not that easy because research is involved. So someone has to, figure out the research questions and make decisions on things. And of course, controlling all the threads, etc. This is still challenging, but well, I mean, you could also argue more people will be able to do sound empirical research. I mean, with my PhD student, Johannes Herdel, I had last year at MSR an award-winning paper where we actually were looking into existing MSR papers in order to figure out whether certain mistakes were sort of made. Or not just mistakes, certain omissions at controlling threads were made. And this was all great research, but yeah, we found some instances where, in some cases, the conclusion was challenged. In some cases, there was a methodological mistake, also in one of our papers, but it luckily didn't impact the results and all this. But, you can learn these things, and yeah.
Yeah, I understand this side, but there's also the other side. As a researcher, I want to learn and teach. The more I can, the more deeper and the deeper I can go, and the more research I can do, the better for me. So if the tool is going to help me in some way, so that's not really a bad point for me in this sense. And but and there is a last question here, and that's from Leilson Silva, and he's saying that with the power of LLMs, we observe these discussion about code copyright. So what's the role of developers regarding code copyright? Who should take the responsibility? Do we need new regulations and laws about that?
Yeah, so I'm not an expert on this, like on anything I talked about, but I think this sort of also relates a little bit to AI ethics and policy, and this is definitely a minefield. And there are some, I think again in this IEEE Spectrum article, there is still quite some legal struggle going on in order to figure out whether things like GitHub Copilot, etc., whether they are doing actually large-scale copyright infringement. So this is the jury is still out. We don't know, and in a way, this is a huge problem. And I don't know. I was probably skipping over it, but I had somewhere a nice slide. Oh, here, this one. I was not going into details, but this is a detail of someone using ChatGPT at Samsung and then getting fired because they were putting proprietary code into ChatGPT. But yeah, I mean, the other thing is really, in best conscience, I'm using ChatGPT. I'm, submitting the code for my student results, or I'm integrating the code into my company system. and maybe I'm opening up my own reputation. Maybe I'm opening up the company to a huge problem here. We don't know really well. I think this is still an ongoing threat. Yep.
Okay, thank you. And now Jaelson.
Okay.
If you read the last one,
Okay.
it's kind of late for you, so but it's very interesting. So we have a last one on Charles. Okay.
Thank you.
Thank you for sharing your insightful ideas. I was wondering, we saw so many questions spanning from career development, teaching, funding, etc. So my question is related to publishing, right? I'm sitting on some PC boards, and I'm observing that if you don't put GPT or AI, in the title of your paper, no, you're not going to publish it. So, what are your views on this? And are we going to see an explosion of papers? So, all sort of, not sometimes very meaningful, but
Yeah.
So, is this a nice place where we can publish papers?
I think it's reasonable to try to contribute to this problem. And I agree with you. It's now really a fashionable topic. And I think you're also hinting at the fact that some authors are very opportunistic at doing this, right? I mean, many of us have not really understood large language models until very recently, and maybe not even now, right? But we can still, do something with it and maybe get a nice publication. Yeah, that's certainly a challenge in terms of quality, maybe, or relevance, or. But on the other hand, there are many research problems related to large language models that should be analyzed thoroughly. So maybe it's okay. I had a workshop paper recently on computational social science research, and there also kind of suggested that's an interesting problem to kind of monitor how research is now developing. Is research now developing in a way that people are kind of generating larger amounts of publications and thereby kind of overcrowding the peer review process, and not just the peer reviewers as humans, but also overcrowding the whole system in a sense that the usefulness of the results will, we will not be able to kind of deliver it to society, right? So this is actually, I found some nice term for this. It's a dark infinity. So this idea that we are kind of, doing too many things and in a too deep manner, so that we are no longer able to understand it thoroughly and use it. So I think this is, yet another challenge related to this publication, publish and perish problem. Thank you.
Okay, Ralf, that's very interesting. Thanks again for the great talk. Very nice having you here. I hope we can have you in person here sometime. There's FSC in Porto de Galinhas next year, so in the same hotel that you have been.
Oh yeah.
A few, more than 10 years ago, I believe.
Yeah.
And we can better control the air conditioning this time, so you'll be welcome here.
Yeah, that sounds great. I will definitely take a look. Maybe I can submit a paper on ChatGPT. Yes, let's see. Yeah. Okay, it was really a pleasure being virtually over there, and I really appreciate your very diverse questions, and I hope some of this was a little bit enlightening. I know everyone is talking about this stuff, but yeah, I think it's still fun to talk about it, right? So thank you. Thank you.
Yeah, thanks a lot, Ralf.